Sige, maayong buntag, good morning sa mga Philippine brads, and then good evening sa mga brads in the US. So welcome sa atong 8th edition sa Trends, Insights, and Developments. So naratay, we only have two main rules, no? During the speaker, while he is speaking or she is speaking, we will all mute our audio. Pero if you have any questions, you can type it sa chat box, and then we will take care of throwing the questions to the speaker after his speech, no? So ang atong our first speaker is going to talk about beer brewing 101. He is a brewmaster, and for clarification, ang brewmaster is a title, ha, dili siya position. Kung sa to liken it to say sa military, like a general or colonel, that's the title, no? Or sa sports, marag chess grandmaster, no? So ang brewmaster is after many years of hard work and learning, naka-earn siya og title as a brewmaster. So ang atong speaker is ang iyang educational background. He finished chemical engineering in UP in 75. Unya nag MBA siya sa LaSalle, and after this he took a lot of brewing courses, supervisor's brewing course in 1989. Top toucher siya sa Polo Brewery, and San Miguel Brewing School in 1984. Top toucher po siya. And also sa BLB Brewing Course in 1986 in Berlin. Third place si Togi, ang atong speaker. And in his work sa San Miguel, he was the assistant brewmaster in 1987, and he became the brewmaster in 1990. And brewing technical services manager in 1994. So which means that he was in charge of all the brewing operations in all 11 breweries in the Philippines and abroad. And later on, he became assistant vice president of San Miguel in 1996, no? Daghang kayo ni siya award, no? Kung part pa ni sa Olympics ning beer brewing, daghan na kay tag gold medal. Kung si Togi, daghan na kay nig awards like sa Great American Beer Festival, which is held in Denver, Colorado. He got 8 medals, 2 golds, 3 silver, and 3 bronze. World Beer Cup, held every 2 years in Chicago, participated by breweries around the world. Doon na siya 5 medals, 2 gold, 1 silver, and 2 bronze. And sa Maryland Controllers Cup, held every year since 2006. He was judged as the best beer in Maryland, no? So he won 4 years in a row, 4 years there, 2007, 2008, 2010, and 2015. And he also conducts basic brewing courses from 2007 to 2017, and daghan nag-graduate about 70 prospective brewers. And sikat kay ni atong speaker because a beer is named after him for his contribution to the Peabody Brewery. So there's a beer called Togi in that brewery, no? So sa iyang work sa San Miguel, he became a main troubleshooter of San Miguel Brewery in the 1990s. And saved San Miguel millions of pesos by correcting and improving operations. And he formulated lots of beer recipes in the US and still being brewed in the breweries there. So, brads, friends, family, please give a warm welcome to our first speaker, Ernesto Togi Igot, batch 68 of Pinoy. Togi, you have the floor now.
Okay. Can you see me? Okay.
Yep.
So thank you for that nice pasakalya, Doji. Now,
Welcome.
good morning to Brads in the Philippines. Well, as Togi mentioned, I'm Ernie Igot. Brads call me Togi. About 68A. Kabas na ko ang binibini, si Jolan Sang. I am from Basilan, but presently residing in Maryland. I wish to thank everyone, especially Berong and Doji, for giving me the opportunity to share my experience and knowledge in brewing. I've been connected with this industry for 40 years, and everyone knows the product that I'm talking to, particularly the palahoogs, like my good friend Alan Caneja. So I'm talking about beer or cerveza. Sorry lang. Now I will try to discuss brewing 101 as layman as possible for clearer understanding. Now, first of all, I'm going to define what beer brewing is. Very simple definition. Beer brewing is the production of alcoholic beverages and alcohol fuels through fermentation. Now, just a background there, I'm going to mention a brief history of brewing. The earliest records of brewing was or is 6,000 years old in Sumeria. Now, Sumeria is the ancient Mesopotamia and the present-day Iraq. Now, after the collapse of the Sumerian Empire, the Babylonians took over. And during that time, surprisingly, they were already producing 20 types of beer. After the Babylonians, the Egyptians took over, and the Egyptians taught the Greeks, and the Greeks taught the Romans. And when the Romans invaded Britain or England, they taught the savage tribes of England the art of brewing. Now, the European beer came to the Americas through Columbus, but Columbus was surprised because the American Indians were already brewing a form of beer from maize or corn. With the advent of Christianity, the monks were on the forefront of brewing. In fact, some of the saints were considered patron saints of brewing, like Saint Columban in Germany, Saint Patrick in Ireland, and Saint Mungo in Scotland. Now, I was thinking also why these monks were on the forefront. Maybe one reason is that they can go around fasting during Lent. Well, this is only my belief. You know, during fasting, you're Catholics, most of you are Catholics. During Lent season, you go on fasting, you don't take solid foods. So these monks don't take solid foods during the day, but they drink beer. And beer is a liquid food. So inom na sila, nasakripisyo sila, hubog pa sila. Now, during the bubonic plague in England, some of these monks also did not succumb to the Black Plague. Why? Because they were drinking beer instead of drinking water from contaminated wells and rivers. You know, beer with the low pH of 4 to 4.5 is very detrimental to the existence of pathogenic bacteria like E. coli, Salmonella, and the bacteria that Yersinia pestis, which was the bacteria responsible for the bubonic plague. So these bacteria, these pathogenic bacteria exist in pH of 6 to 8. But the beer has a pH of 4 to 4.5. So these bacteria cannot exist. Now, in 1516, the the Germans, particularly in Bavaria, they instituted the Reinheitsgebot, which is the purity law. Now, it states only that beer should be produced using only malt, hops, and water, and nothing else. No chemicals, no other components, only, well, aside from the yeast, of course. Now, unlike today, you can put anything in your beer. You can put chili, you can put coriander, you can put oranges. But before, during the Reinheitsgebot time, well, some of the breweries in Germany still practice Reinheitsgebot. They only use these three components or three raw materials in beer. Now, up to today, the brewing world is looking up to Germany for technical developments and researches in the form of their brewing schools and their breweries research and development. I, for one, as mentioned by Togi, is a product of this brewing school in Bauelbe in Berlin. I studied there for 5 months in Berlin before the wall came down. I was there 1986. The wall came down 1989. So the beer and brewing really progressed from that time when we were teenagers. We were only drinking pale Pilsen, Cerveza Negra, or Red Horse, up to today when we can drink 90 to 100 different types of beers, like IPAs, double, triple IPA, Sipe Weizen, wheat beer, lambic beer, sour beers, fruit beers. There are lots of many varieties of beer now. Now, brewing technology and equipment also has transitioned from a single brew a day using a copper kettle, doing it manually, and fermenting in open fermenters, to big breweries now using sophisticated and computerized equipment, brewing up to 10 to 12 big brews a day, using very huge 7 stories stainless steel fermenters. Now, if you pass by Mandawi, you can see all those tanks there. And you pass by Polo, you can see all those vertical tanks there. Now, it saved manpower and it improved the volumes of the beer produced. Now, how do we make beer? So, well, why do you bother in how beer is made? You just go to the liquor store and buy what type of beer you like. But anyway, brewing beer involves 2 factors. One is raw material and the other is the process. Now, the major raw material in brewing is malt. Now, malt is produced mostly from barley grains by letting the barley seeds or grain germinate for a given time, and then it is arrested by passing hot air to arrest the germination. So the grain from a very, like rice, when you bite it, the initial barley grain is hard and glassy. Now, after a certain how many days of germination, the inside of the grain becomes powdery. So this is very useful in brewing, making it powdery. Now, after passing hot air through the grains are passed through a special equipment that removes the rootlets. So you see the grain produces roots. So the special equipment removes the rootlets and the grain is devoid of rootlets. Now, depending on the type of beer you produce, you can manipulate your kilning temperature, the moisture, to produce different types of malt to use in your recipe. For example, if you want a dark beer, you use black malt and or chocolate malt. Now, you get black malt by kilning at a very high temperature, for example, at 250 degrees centigrade, compared to the malts used in pale Pilsen, which is kilned only at 81 degrees centigrade. So the malts, your beer will become dark using these malts. Now, what is the second raw material? The second raw material is hops. Now, hops come from the flower of the female hop plant. So it comes from the flowers of the female hop plant. Now, the male plant, like the papaya plant, is useless, and you cut it down because only the female hop plant produces these flowers, and they're the ones contributing to the bitterness and aroma in beer. Now, as an analogy, I think this will be my good friend Alan will say that is true. As an analogy, compared to human life, bitterness is always produced by the female, and some of the males are useless. I hope not the broads. Now, these hops come in the form of dried leaves, pellets, or extract. So, these hops give the bitterness in beer. Now, can you guess the third major component of beer? Anybody can guess the third major component in beer? Well, the third major component of beer is water, and this is available everywhere. But the water should meet the brewing standards. So in terms of clarity, in terms of chemical composition, in terms of water hardness. Now, compounds like gypsum, calcium sulfate, calcium chloride are added to adjust to the brewing standards, because you cannot just use soft water when you do, for example, an ale or an IPA. You have to add additional calcium sulfate to make it hard. Well, I hope you understand what soft water and hard water is. Anyway, that is the third component of brewing. Now, we are using also other raw materials like sugar. So we use sugar either in grain form or liquid form to complement the sugar produced during mashing, which I will discuss later in the process. So, for example, San Miguel Pale Pilsen uses 25% sugar, and 75% is malt. Now, another raw material used is rice. So rice also contributes to the sugar content of the beer later. But you cannot just use rice in the Philippines because it's a staple food. So during my time in San Miguel, we import broken rice from China. So when we receive this broken rice, we mill it into powder and then boil it in a vessel called a cereal cooker. So this cereal cooker, by boiling, it will release the molecules which will be reacted by the enzymes which are inherent in the malt itself to convert sugar, to convert the starch to sugar, which I will discuss later. Now, other raw materials are, the fruits you are using. We use different type of fruits to put flavor in the beer: strawberry, raspberry, cantaloupe, mango, to get our desired flavor. Now, you might ask why yeast is not a raw material. Yeast is a single cell organism which serves as a catalyst to convert starch to sugar and to alcohol, ethyl alcohol, and carbon dioxide. Now, the yeast does not go into beer. The yeast settles and is removed from the beer. So it's not a raw material. So these are the main materials in making beer. Number one is the malt from barley grains. Number two is the hops, which provides the bitterness. And of course, the water and the other auxiliary materials, other materials like rice, sugar, and the fruits. Now, let's go to the process. As I mentioned earlier, there are two factors in making beer. It is the raw materials, which I already discussed, and the process. Now, the first step in the process is milling. Now, I mentioned earlier that after malting, the grain, the inside of the grain is powdery. So what the process of milling using a malt mill, a roller mill, is to break the grains open to release what's inside of the grain. So it's to release the extract from the grain, because this is very important during the next process. So you mill a certain amount of malt based on the recipe you have, or a combination of different types of malt. So you crack them open to release the starch inside, or starch or carbohydrates, if you want to call it. So the next step after milling is mixing the milled malt with water in the process we call mashing. So we mix the milled malt with water to produce a mash or a dough. Now, this mash or dough is subjected to a time and temperature sequence, the objective of which is to convert the starch into simple sugars. So the purpose of mashing is just to convert the starch, the powdery starch, into simple sugars, because the yeast can only metabolize simple sugars like glucose, maltose, and maltottriose. The yeast cannot metabolize complex sugars like dextrins, etc. So they, as I mentioned earlier, mashing is just to convert the starch into sugar. Now, after the conversion, the mash is passed through a process called mash filtration. It is passed through a mash filter, or a technical term we use water tan. So it's just a spring. So the main purpose of mash filtration is just to separate the liquid portion, which we call wort, WRT, from the spent grain, from the bagaso. So the wort is received by another vessel called the brew kettle. Now, when all the wort has been emptied in the mash filter, we add water in the process called sparging. This is just to leach the remaining sugar in the bed, in the spent grain. So it is collected together in the brew kettle. Now, the spent grain is given to the farmers, or the farmers buy it, because this is a very good food for hogs and the cattle. But the wort which is collected in the brew kettle is subjected to 1.5 hours of boiling. So this is just to stabilize the characteristics of the wort, the color, and then the sugar content, and then to sterilize the wort. And then it is during boiling also that the hops are added. So the hops that gives bitterness and aroma in beer are added at different times during wort boiling. Now, after that, the wort is centrifuged, which we call in brewing whirlpooling, to separate the solids. Because when you boil the wort, it produces solids. So the solids during centrifuge, it settles down. So what you are just interested is the clear wort. So after boiling, after producing that clear wort, after boiling, you go to the process called wort cooling. So in wort cooling, the wort is cooled from a high boiling temperature. I told earlier it is being boiled, so it's 100 degrees centigrade. So it's cooled from 100 degrees centigrade using a wort cooler to 12 degrees centigrade if you are producing lagers, because there are two major types of beers, lagers and ales. So you cool it down to 12 degrees centigrade if you produce lagers. You cool it down to 20 degrees centigrade if you are cooling ales. So ales like IPA, Hefeweizen. So after cooling, after passing through the wort cooler, it is the wort. It's not yet called beer. It's still called wort. The wort is aerated because you need air for the initial metabolism of the yeast. Now, the cooled wort is collected into a vessel called the fermenter. Now, yeast during cooling can be injected online, or the yeast can be placed already in the fermenter, so that when the wort comes in, it mixes with the yeast. Now, the next step after that is if you ask me, it's the heart of beer brewing. It's fermentation. Now, fermentation, as I mentioned earlier, fermentation for lagers occur at 12 degrees centigrade, and fermentation for ales occur at 20 degrees centigrade. Now, during fermentation, the yeast, which is a single cell organism, reacts with the simple sugars, the glucose, maltose, and maltodextrose. So they metabolize these sugars, and the product that they produce are ethyl alcohol, which makes the people drunk. And also, one of the byproducts is carbon dioxide, which they release to the atmosphere. So fermentation, normal fermentation occur from 6 to 8 days. So after 6 to 8 days, fermentation is done. So what do we do after fermentation? The yeast settles down. We reduce the temperature from the specified temperature I mentioned earlier to -1, to a very cold temperature. So this is the process we call beer maturation or beer storage. Now, when it's cooled down, all the solids, most of the solids settle down, including the yeast, and this is removed. And beer maturation can happen or can occur from 1 to 4 weeks, depending on what beer type you're making. So after 1 or 4 weeks of beer maturation, the beer is now ready for filtration. So there are two aspects in this. One is beer filtration. You filter off the residual yeast, because there will be yeast floating around yet. You remove the protein and other impurities to produce a clear beer, like the beers that you're drinking, like San Miguel. They're all clear. So they pass through filtration. Now in microbreweries, they skip this process. They sell the beer as is. So the beer in microbrewery mostly are hazy because they don't undergo filtration. So either they are filtered or not filtered. They go into the next process. Well, it is called packaging. So in packaging, the beer is transferred to a bright beer tank where the carbonation is corrected. Well, to give you an example for carbonation, the carbonation Coca-Cola is 4.0. Well, I need to explain what CO2 volume is. So the carbonation Coca-Cola is 4.0 CO2 volume. The beer is lesser. It's about 2.5 to 2.7 CO2 volume. So when it is corrected already in the bright beer tank, it is ready for packaging. So it's packaged in cans, in bottles, or in kegs. And after packaging, it is now ready for selling, for consumption. Now, there are other auxiliary processes in beer production. Well, I just mentioned two. One is what we call the process of dry hopping. So I mentioned earlier, the hops are added during boiling of the wort. Now in dry hopping, The hops are added during maturation, during storage, when it is already -1. So the main purpose of adding hops, particularly pellet hops, is just to improve the aroma of the beer, particularly if you're doing IPAs, double IPAs, and other types of beer that requires aroma. So this is dry hopping. Now the next process, auxiliary process, is called, which is familiar to everyone, it's called pasteurization. Now, pasteurization is the process where you subject the beer to a high temperature short time. And the main purpose is to improve the biological stability of the beer, to improve its shelf life, how long the beer can last before it tastes rotten, and maintaining the flavor. Now, you subject it to high temperature short time because you want to kill bacteria, if bacteria is still present in the beer. Well, in microbreweries, because of the very sterile conditions we are doing from boiling it to cooling it to fermentation, cleaning the tanks, normally we don't do pasteurization in microbrewery. We sell it right away from the storage or maturation. So mostly the breweries doing pasteurization are big breweries like San Miguel or regional breweries. So they pasteurize their beer so that they will last long in the market. So if you, like San Miguel, if you pasteurized, or San Miguel, the shelf life is about 1 year or more than 1 year. But microbrewery will last only maybe 2 months or 3 months. So you have to drink it right away. So as mentioned by Togi earlier, well, anyway, I have to summarize first. The processes I discussed was, number one is milling, mashing, then filtration, then work boiling, then cooling, then fermentation, then beer maturation, then packaging. So these are the main processes in making beer. Well, the auxiliary process are only auxiliary process. So as Togi mentioned earlier, he mentioned all my, thanks to Togi, he mentioned all my credentials on becoming a brewmaster. So just to reiterate, well, he mentioned the analogy between a brewmaster and the military colonel. So it's a title. So the position in brewing is head brewer or brewing manager or production manager, but the title is brewmaster. So the same as in the military, the title or the rank is colonel or major, but the position is he may be head of logistics, he may be head of the 4th Infantry Brigade. Now, another good example is this is just beyond the discussion. So another good example is Mr. So for example, I hope my good friend Alan will not take offense. For example, Mr. is a title. So Mr. Alan. So that is his title. But what is his position? He is the husband of a wife or the husband of many wives. So when Alan will divorce his wife, he loses the position. But he is still a Mr. unless he undergoes the exchange operation. So this issue, now, as I mentioned earlier, this being brewmaster is earned only if you pass certain standards or criteria, and it is formally presented or awarded to you by an institution like a brewing school, or in my case, it was awarded to me by San Miguel. So this condition is very unique in the US. So whenever I mention this during when I do some lectures, some of the people get pissed because in the US, they mistake brewmaster, they mistake the title and position as one. So these guys, there are lots of thousands of microbreweries in the US. These guys, they brew, they start brewing, and after 3 to 5 years brewing, they already call themselves brewmaster. So they award the title themselves. They're already brewmaster. You know me, I earned this title in San Miguel after 14 years of lots of training, attending seminars, schooling. So 14 years. I was awarded brewmaster in 1919, McCullough Brewery. So that's just to clarify the title and position. Now, you want to start a brewery in the Philippines. So what will you do? Now, I'm not talking of home brewing, because home brewing involves only brewing at home using a 50-liter vessel, like a keg. A keg, you see kegs around. So you just do your home brewing there. I'm talking about commercial microbrewery. Now, let's define what a microbrewery is. It is a small brewery with limited capacity and whose beers are sold in a certain locality, like a brew pub or a city or a town. So it is a miniature version of the big breweries you are seeing in the Philippines, like the San Miguel breweries. Now, but basically the process in home brewing, microbrewing, or big time brewing are the same. They undergo the same process, except they have different equipment. Now, in the US, a microbrewery is defined as a brewery that produces up to 18,000 hectoliters of beer annually. Now, in brewing, we don't say liters, we say hectoliters. Now, 1 hectoliter is 100 liters. So if you say 1,000 hectoliters, you add 2 zeros, it is how much? 100,000 liters, but we use hectoliters in beer brewing. So in the US, if you produce up to 18,000 hectoliters, you are called a microbrewery. Now, if you produce from 18,000 hectoliters to 7 million hectoliters, you are called a regional brewery. So if you're familiar, if you went to Pennsylvania, there is a regional brewery called Yingling. So it's a regional brewery. So at most it only distributes in the region. Now, if you go beyond 7 million hectoliters a year, you are now a national brewery. So these are like San Miguel, Kirin, Anheuser-Busch. So this is called a national brewery. Now, any brand who is interested in putting up a brewery, my advice is you should have the passion for brewing, and not only brewing, but the product itself. You should put your heart in this endeavor if you want to go into brewing, into building a brewery. Now, another thing also is basically you should have financial capability to build a brewery. Well, as I mentioned earlier, I'm talking of a commercial microbrewery. Now, the third one is you should have basic knowledge in the beers that you want to produce through maybe taste testing, reading, or researching. So how do you go about building a brewery or planning a brewery? So the first thing you will do is to do, well, as in MBA, you do a feasibility, some sort of a feasibility study. Now, you have to do this before you have to wet your feet, because this is a long-term investment. It involves a lot of time and money. So when you start, you have to finish this endeavor. You have to finish the microbrewery that you want to build. Now, what are the things? Ha? Ano sa problema? Okay lang?
Okay lang.
Okay lang?
Sige, sige. Continue.
So, okay lang? Madunggan ko
Okay
ninyo?
ra. Okay ra, Togs. Okay ra.
Madunggan ko ninyo? Wala
Okay.
man okay man sa ako diri.
Yan na. Oo.
Yeah,
Si
okay.
Mike.
I can hear. I can hear.
Yeah, we
Okay.
can hear you.
Okay. So,
Proceed.
in the feasibility study, you have to consider your target volumes initially. What volume do you want to produce in, for example, in cases? What and what type of beer do you want to produce? Do you want to produce mainstream beers like pale pilsen or IPAs, or do you want to produce sophisticated beers like sour beers, lambic beers, or fruit beers? So you have to have that in your target volume also. You have to know how much, because this will determine your design of the brewery. So you, if your target volume is big, you have to design a bigger brewery. If your target volume is small, you have to design a smaller brewery. Now, the second thing is you have, aside from the volume, you should have an idea where you want to sell this beer, your marketing goals. So is it only, do you want only to sell in-house or in the brew pub, in the restaurant? So you just produce beer, selling it in your restaurant, in your brew pub? Or do you want to distribute in the city? Or do you want to sell it in other restaurants? Or do you want to sell it in the region, like the Visayas or the whole of Mindanao? Or do you want to sell it nationally? So you have to consider that also. Now, well, this is far beyond the feasibility study already. What profit margin do you intend to do, or how do you assess the competition? But this is already beyond the feasibility study. Now, when you finish your feasibility study, you now proceed to planning and building the brewery. Now, as I mentioned earlier, the most important thing is, financial capability. Of course, you have to have the needed capital. Excuse me. The quotation I got from the US 2 years ago to build a 10 hectoliter brewery, we need about $500,000. So if you convert it to pesos, maybe roughly 25 to 30 million. Now, this 10 hectoliter brewery can produce 1,000 hectoliters or 11,000 equivalent cases of 24s in a month. So if you extrapolate, you want lower, so you go from maybe 10 to 8 hectoliter to 5 hectoliter. So to reiterate, the 10 hectoliter brewery, which will cost maybe a complete 10 hectoliter brewery, which will cost maybe in US dollars, maybe $500,000 or 25 to 30 million, can produce 1,000 hectoliters or 11,000 cases of 24s, case ng beer, per month. Okay, per year, well, you just multiply by 12. Now, the cost of the brewery or the brewery equipment will lessen if you will have the equipment or the tanks or the vessels fabricated locally. because it's very, very expensive to get it from the States or from China, because you have to import, you have to consider customs, taxes, etc., the shipment. But if you have it produced locally, you will save a great deal. Now, I mentioned financial capabilities. So if you have an amount stated for this already for building brewing, you should have an amount also for operating costs. So normally in the US, you can only realize profits after 1 or 2 years of operation, because initially you have to build your volume, you have to gain clientele, and then you are paying your mortgage, your amortization with the equipment you're buying, etc. So normally it takes about 1 to 2 years to make a profit in the US. So maybe this is also true in the Philippines. Now, in planning the brewery, well, number one is financial capabilities. Number two is you have to observe the operations. This will help your feasibility study. You have to observe the operation in an existing microbrewery in the Philippines. Now, a good through my internet, sourcing, I come across Crazy Carabao in Santa Rosa, Laguna. Maybe before you get your feet wet, or you have to go there and then you have to observe, you have to ask the owner, or maybe anyway, you're not competing with them directly. You have to ask them where they got their equipment, where they are getting their raw materials. So to gain some insights, your only purpose is to save some money, and then to get the equipment or raw materials in established pattern already, like Crazy Carabao. Now, the third one is plant and equipment layout. Now, after you zero in on the plant location, you have to design the brewery layout already. So you know where to place your, the process earlier, you know where to place your malt mill, your mash tun, your mash filter. So this will also determine the area that you can, the location, the area that you purchase or you buy. Now this will include also the location for a cold room, for the utilities like a boiler or the cooling system, or the CO2 tank, because you need to carbonate your beer, and the wastewater treatment, which is very important. Nowadays, the government is putting very good emphasis on the wastewater, where you throw your waste, particularly in brewery, because you'll be throwing effluent. You'll be throwing effluent with high pH, with high temperature, high protein. So this will, if you just throw it in the river, it will affect the balance of the food, the food chain in the river. If you throw a low pH and the river is 6 to 8, and you throw a 4 or a 3 pH, so it will to some extent damage the fish or kill the fish. Now, make some also when you design the brewery in the layout, make allowance also for expansion in the future. What if your beers are selling like hotcakes, so you cannot cope up with the production with the tanks that you have? So you should have an expansion area for additional fermenters, additional bright beer tanks, etc. So additional.
Excuse me. Folks. Excuse me. It's 5 minutes na lang.
Oh, okay. 5 minutes? Dugay di ko. So,
wala na Q&A. 5 minutes na lang.
Huh? Okay, sige. So, gamay na lang mani. So, brewery location. Location, you have to set your brewery in a location where there's good water, power supply, good drainage, and you have to consider also the situation of the neighbors. because you will be brewing, and then there will be smell, noise, and you don't want your neighbors to complain. Now, sourcing, as I mentioned earlier, you can have it fabricated locally. You can also get it from the US, brand new, or you can search the internet for second-hand equipment, because some of the microbreweries here are folding up because they're bankrupt, so they're selling their equipment. So you can go to the internet and maybe get some at the bargain price. Now, raw materials, you can only source malt and hops from abroad. We don't plant barley here, and we don't have hops because the hops are temperate, the temperate plant, and the barley that can grow on tropical climate is a bad quality. So it normally grows in temperate areas. Now, the last one is you have to consider government requirements like taxes, licenses, inspection frequencies, environmental concerns. Now, when you start a brewery, during construction, you can already, assuming everything is okay, you have your equipment. When you're installing it, you can already train your key personnel, like the brewer. You can already train administrative personnel or maintenance people. So the important thing is to train your brewer, because the brewer is the one brewing the beer. So the brewer should have some knowledge in chemistry, in equipment maintenance, in inventory control. So you will do some readings, or to some extent attend the brewing course, even on the internet. And the next one will be your trial run. So the equipment, when you install it, should be clean, passivated, sterilized, and you do initial water brew instead of the mash and water. You do a water brew to test the efficiency or the capacity of your heating, your cooling, the equipment. Now, the first brew, when you brew, you have to have a checklist of everything that is required, everything, the materials, raw materials, the equipment, the analytical equipment. Now, after 18 to 20 days, you have the beer already produced when you brew it. Now, what criteria do you judge your beer, the beer that you produce? Now, tasting it, you can adjust your bitterness, you can adjust your alcohol. Now, you can rate your beer to the following criteria: taste, aroma, bitterness, clarity, appearance, and middle and last impression. Now, other beer qualities like alcohol content, the analytical bitterness, the pH, can be derived by using equipment. Now, the best way to personally judge a beer is through you. If you taste the beer and it is good for you, then it is good for you. It deserves another round. Now, anyway, the advice is always drink moderately. So, in conclusion, I hope you learned something from my Brewing 101. And to any brad who is interested in putting up a brewery in the Philippines, you can help me as a technical consultant. Now, the desire should not be half-hearted, because I remember 4 years ago, I made some studies for a group in the Philippines. They wanted to put up a microbrewery in the Philippines. So I did some work, I did some technical work, and after some time, they backed out. So it was a waste of my time. Okay, so thank you very much, everyone, for my Brewing 101. Now I'm open for questions.
Okay, so thank you, Brad Togi, for that very interesting discourse on beer brewing 101. So, Brad, we would like to advise everybody na may mga questions to just type it first sa chat box, na since we are running a bit late. Mag-photo sessions ata, no, before we go to the second speaker. Please type your daghan na kay questions nga gi-type, no? But anyway, open nyo na lang ang mga video para okay.
Rosen, Sigmund, Mark A, Boigo, and maybe Camille. Camille, our speaker. Pwede maka-on cam. Okay. 1, 2, 3, 4. And page 2. 1, 2, 3. Okay. Got it.
Okay, so now we go to our second speaker. She's the daughter of Brad Fred Avestruz, batch 64B. At a very young age of 34, she's already a very highly accomplished doctor of science. She's presently a tenure track assistant professor of physics at the University of Michigan, Ann Arbor. Previously held fellowship appointments at the Kavli Institute for Cosmological Physics, University of Michigan, Enrico Fermi Institute, University of Chicago, and was provost postdoctoral scholar, astronomy and astrophysics at the University of Chicago. For her education, she has a PhD of physics at Yale University, and her thesis was titled Cosmological Simulations of Galaxy Clusters Outskirts. And she received an honorable mention for the Roger Doxey Dissertation Prize from the American Astronomical Society. She also has a BA in physics, mathematics, dance, cum laude, Barnard College, Columbia University. She had her high school at Phillips Exeter Academy at New Hampshire. That's the high school alma mater of Mark Zuckerberg of Facebook, by the way, and Dan Brown, the author of Da Vinci Code. She has several awards and grants in honor, her name given by Andrew W. Mellon Foundation, also American Astronomical Society, Ford Foundation, National Science Foundation, NASA, Harriet G. Jenkins Predoctoral Fellowship Projects, where she was a semifinalist, Howard Hughes Science Research Internship Award, and she has published more than 40 articles in professional journals in cosmology, astrophysics, and astronomy. And she has some of her hobbies include rock climbing and piano. So Brad's friends, family, to talk to us today about tools to understand our universe, please welcome Dr. Camille Avestruz. Camille, you have the floor now.
Hi, thank you very much. Thank you, Tito Togi, for that very kind introduction. And thank you, Tito Oliver, for inviting me in the first place. I do want to thank the overall community for maintaining this wonderful space. Despite the pandemic, you're finding a nice opportunity to get together and stay in touch. I think that's very, very rare and very valuable nowadays with what's going on globally. So let me share my screen. All right, so just to check, I think that is visible. Okay, so what I will be telling you today is how we use galaxy clusters as a tool for cosmology. And just as a side note, sort of just a hat tip towards the previous presentation. This is a presentation based on what I had previously given before the pandemic and an Astro on Tap series. So basically these public lectures that we would give at local bars. So I wanted just to, so the San Miguel is very appropriate here. Okay, so galaxy clusters as tools for cosmology. Let's first just talk about this beautiful image that I put in the first slide. And this is an image of the Milky Way, our local galaxy, what it looks like from our perspective sitting on Earth. So you see this beautiful bright band straight across the sky because the Milky Way is shaped like a disk, and this is us looking in the direction of where we have many more stars, so it is brighter in the night sky. But you cannot see this Milky Way if you live in a major city where there is a lot of light pollution. So I was born and raised in New York City, where I didn't see too many stars growing up. So the first time I do remember seeing the Milky Way was when I was visiting my mother's hometown, Pasig City in Iloilo. And I remember I was like around 4 years old. I looked up into the night sky. I saw this beautiful band and I thought, what is that? It kind of looks like bright clouds, right? It's either very cloudy here or very or very polluted. If it must be some kind of a smoke effect. I just didn't understand what that was coming from. And it was just very peculiar to me. And it wasn't until years later that I realized this is actually a beautiful component of our night sky and a beautiful component of the structures around in our larger universe. So growing up in New York City, I did not have much exposure to the night sky. I first saw it when I was in the Philippines and didn't find out much about it until many, many years later on. So I'll talk a little bit more about the Milky Way in the context of galaxy clusters. So this is an image of a galaxy cluster where you can see sort of this hue of like X-ray emission. So this is certain kind of light in purple, and then individual galaxies that belong to the galaxy cluster. And primarily what I will be describing to you and what I hope that you will take away is how we can use these types of astronomical objects as tools to understand cosmology, where cosmology is simply the history of our universe. All right, so you probably are wondering, I've used this term galaxy cluster. So what is a galaxy cluster? Let's start with what we know. So we know we live on a planet called Earth, right? And you know that Earth is actually one of 8 planets orbiting the sun and Pluto. So when I was a child, and probably all of you learned that there were 9 planets, including Pluto, but that Pluto got demoted in the last decade because of certain properties it has. It's not quite planet level as the other 8, like Earth. And these planets, right, it's a part of our planetary system, which is comprised of the sun, planets, there's asteroid belts. This is our local planetary system. So one little tidbit is that our sun is actually a star. And this star is one of many stars in our galaxy called the Milky Way. And not just many stars, but billions of stars. So when I talk about a galaxy, right, there's our galaxy, the Milky Way, and in the lower right-hand image, you see what a galaxy looks like from within. So that view that we saw in that very first slide. So we look from within and we see this bright, beautiful band. And if we look at yet another galaxy, such as the one in the lower left-hand side, you can see just this sort of bright, either disky or oval-like shape, full of also, thousands to millions to billions of stars. So you'll notice that the image in the lower left-hand side kind of looks like this very disky object, right? Full of stars that illuminate in a disc-like fashion. So why does the Milky Way look like this bright band across the sky? Well, if you think about it, right, if you have a galaxy far away, right, you could look at it face on, so it kind of looks like a band. From the side, it can look very flat and oval-like, and sometimes it has some other funny shapes. Our Milky Way looks very much like a disc. Now, if you imagine sitting inside a disc, so maybe the plane of your hand, if you were sitting inside the plane of your hand, if you look up and down from like in between your fingers, you don't see a lot of your hand. But if you look straight across, you see mostly hand. So similar to that in the Milky Way, if you're looking above the plane of the Milky Way or below the plane of the Milky Way, you see some stars, but not a bright band. If you look straight through the Milky Way, this corresponds to that beautiful band in the sky. It's just the direction inside the galaxy that we're looking in that leads to that feature. So galaxy clusters are if you take many such galaxies like our own Milky Way, in fact, taking hundreds of those to thousands of those, and you allow them to just all collapse into one another to form one giant object in our universe. So what that looks like is this image on the upper left-hand side, right, that I sort of flashed earlier on. So a galaxy cluster is comprised of hundreds to thousands of galaxies. So this is each of these galaxies are comprised of billions of stars. And when all of these objects collapse into one another, it converts the gravitational potential energy into heat. So what happens is that in between all of the galaxies in this medium inside the galaxy cluster, it gets heated to the super hot plasma of millions of degrees. So when you're that super hot and super energetic, you emit light in the X-ray, very much like the kind of X-rays that you use to when you have to X-ray your bone structure if you twist an ankle and you want to check if it's broken. So that purple hue is the X-ray signature of galaxy clusters. So again, right, like let's zoom in on that galaxy cluster. Each one of those bright spots in different colors and different shapes corresponds to individual galaxies that belong to this galaxy cluster. But in addition to their sheer mass and in fact they're this ginormous ball of a bunch of galaxies, they're special in another way. And the reason they are special is because they are the most massive collapsed objects in our universe. In fact, so the mass that they are comprised of, it's a lot of mass, but mostly in the form of what's known as dark matter. So this is stuff that has some mass, like you and I do, but we cannot see it. It does not illuminate. I am luminous. You can see me because light bounces off of me. I can see you. I can see everything around you. But dark matter, that's not how we know that that exists. We only know that it exists because of how other objects that are light emitting behave around it. So a lot of mass, mostly in the form of dark matter, ended up falling into one another, fell into itself, so galaxy clusters could exist in the first place. This is how structure formed in our universe. So gravity leads to structure formation. Probably whenever it is that you last took physics, you heard about Newton's sitting under an apple tree and apple falling on his head, and that's just like, there's something that causes the apple to fall on my head. This is how Newton's theory of gravity started to come about, or at least that's the that's the storyline behind it. We don't know if it's necessarily true. So the kind of structure that gravity leads to in our universe looks just like this purple hue in the lower right-hand side of the screen that you see. It probably looks a lot like neurons in the brain, as some of you have seen that image. So gravity leads to structures that form in ways that look a lot like neurons, where we have these very bright, dense spots and these very like gappy voids in dark in between those bright, dense spots, and this filamentary structure connecting all of those nodes and filamentary connections that essentially make this intertangled web that we actually call the cosmic web. So this is just a quick little visual of how structure forms from gravitational collapse over time. This is from a simulation that only includes dark matter behaving under the influence of gravity, where you see that bright spots over time as you're rotating around, it becomes brighter and brighter and brighter. So this is just like the picture of the rich get richer and the poor get poorer. Parts of the sky, parts in our universe that have more mass collect even more mass, and parts in our universe that had a little bit less mass become voidier and just lose their mass to the parts of the universe that have even more mass. That's the dark regions. So yeah, gravity leads to structures forming, but gravity actually has a competitor in how our universe formed. So the way we learned about this is that when people made observation of our universe, what they realized is that our universe is expanding. So if you take a look at the little dots on the surface of the balloon this woman is blowing up on, right? As she blows the balloon up, each one of those dots gets further and further apart because the space that the balloon takes up is expanding. And what we found is that this is true of the galaxies in our universe. So our universe is expanding as we look further back in time or further out in space. It looks like the universe has been expanding at an accelerating rate. So it's slower, further back in time, and faster now. So our universe is expanding at an accelerating rate. This means that there's some kind of force, this unknown thing leading to the accelerated expansion of our universe. Right? So picture again, us say in the Milky Way and us looking at some other galaxy in the distance and trying to measure how quickly it is moving away from us because space is expanding like this balloon is. So this is a thing that is opposing gravity, which brings things together like a really heavy suitcase. It's very difficult to pull a suitcase away from the ground because gravity, due to Earth, is keeping the suitcase as close to the ground as possible. So something like us pulling up is opposing gravity. What we call that is dark energy. It's this mysterious thing. We don't know exactly what it is. It's this mysterious dark energy that fights gravity. So what we come to realize from observations is that earlier on in time, gravity is winning, and later on in time, close to the present day, dark energy is winning. And depending on who is winning at which point in time is how we start to describe the history of our universe. So our universe, what we know about it so far is that the energy budget of it in the current day is mostly in the form of this mysterious dark energy. So just to talk through this pie chart, right? The atoms are the things that are luminous that we better understand and we can look at directly in a laboratory. So like the Earth, the sun, us, these are made of atoms, but that's only about 4% of this entire pie chart of what the energy budget of our universe is. 23% is in the form of this cold, dark matter. Most of the mass in our universe is in the form of dark matter, which is not luminous, but we have guessed of its existence because of how we see other objects that are luminous, how atoms behave around it. So if you look at how stars behave in a galaxy and how they are distributed in a galaxy, we know that this implies that there must be some additional mass that we cannot see, and that is dark matter. Now, finally, right, dark energy, just to summarize the things that we've talked through, is in the form of dark energy, this cosmological constant that leads to accelerated expansion of our universe. So both dark energy and dark matter, which is about 95% of the energy budget of our current day universe, are things we do not understand. So just let that sink in. We only understand about 5% of what our universe energy budget is made out of. There's a lot we don't know. So when we think about how we can probe what dark energy and dark matter are doing in our universe, these are different forces that change structure. So an analog to that is if we look at how structure formed, say in lower New York City. So I grew up in New York City. This is lower Manhattan, the island, one of 5 boroughs in New York City, where you can see in the very lower part of Manhattan, there's these sort of crisscrosses of streets that don't look very organized at all. So back in the day, when streets formed, the way it did when people started settling into lower Manhattan was anytime a carriage went through and cleared a path, another carriage would be like, oh, hey, someone made a path there, let me go through there as well. And then so now a random street started getting created because more and more people use something that other people have created. But it wasn't really created in that organized a fashion. So there's this runaway structure formation of streets. As people pushed further and further upward, developing additional neighborhoods as they moved upward and north in Manhattan, there's a driving force that created structure called city planning. People realize it's easier to find directions if you have streets that are aligned north, south, east, and west. So city planning created structure in the form of this grid. Before that structure took place, runaway. Similarly, with dark energy, when dark energy kicked in later on in the history of our universe, it changed the matter distribution. So one of these is what the matter distribution of our universe looks like with dark energy, and the other one without. So dark energy suppresses structure formation. Which one of these do you think contains dark energy? The one on the left or the one on the right? Anyone can just call out an answer.
One on the right.
The one on the right. Any other thoughts? I just want to get a little bit of a poll. Who thinks which one's which? Well, it looks like it's more pulled apart to people, left or right. I heard a right. Any others? Left? Any others?
Yeah.
Left?
Yes.
I got a
Center.
left, one on the right. Sorry, did I miss another one?
Left.
Left. Okay, 3 on the left, 1 on the right, I think so far. All right.
Left.
So the one on the left is the one with dark energy, and the one on the right is the one with no dark energy. So
See?
when matter collapses, right, you form larger and larger objects, and things that didn't really quite form bright spots form little tinier spots. But once dark energy starts to kick in, it pulls the clumpy structure further and further apart, forming these voids, this black gaps in between the really bright nodes. And that's what happens on the left side when dark energy kicks in. And the right side, things are just continually collapsing, 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 collapsing. So you end up seeing just almost like this fractal-like feature of just nodes and smaller nodes and smaller nodes and smaller nodes, but not so much of the gappy stuff that we see on the left side due to dark energy pulling things apart. So galaxy clusters live in the densest, most massive knots structures. So you see there's a lot of bright spots here, and some spots are bigger and brighter than the others. The biggest and brightest ones of these are where galaxy clusters live. So because dark energy affects how all of these structures are distributed and formed, dark energy and dark matter also affects how galaxy clusters form as a function of time over the course of our universe's history. So what we do for some cosmologists like me who use galaxy clusters as a tool is we want to know how many galaxy clusters in each mass range, so like the smaller ones versus the medium-sized ones versus the really, really large-sized ones, how many of them in each sort of mass range exist? Is it many more or a little bit less at each point in time? And that gives us a sense of the history of our universe, right? The underlying question there is we want to figure out who wins at any given point in time and by how much. So this gives us the sense of, right, with gravity's opponent being dark energy, that gravity is something that's winning earlier on in time, and at some point, dark energy starts to kick in and dominate in the fight. So at the present day, dark energy, as far as we have seen, is the winner. But earlier on in time, before Earth existed, before our solar system existed, gravity was the one that was doing pretty well. So just to give you a sense of what that might look like, right? So, right, remember the gappier one with all those like voidy black spaces in between structures was the dark energy. We count the number of galaxy clusters in different mass ranges as a function of time, right? We make a plot that's the number of galaxy clusters versus galaxy cluster mass. We look at that earlier on in time, and as structure continues to form, we look at how that evolves. So earlier on in time, later on in time, you get a little bit more structure. Without dark energy, right, it's this evolution of this curve will look a little bit different. And that's how we arrive at these cosmological constraints and find out parameters that constrain models, theoretical models of our history of the universe. So what that actually looks like, let me just show you some real data. This is actually from more than a decade ago. So we've been able to do this for quite a while. We're just getting better data and better models to figure out how to constrain the data. So this is showing that number of galaxy clusters as a function of their mass. In blue, I'm showing that earlier on in time. So what does earlier on in time mean? It's about 5 billion years ago. And then in black, later on in time. So that's about 300 million years ago. That's recent. In cosmology speak, 300 million years ago is a recent point in time. So what we do is, right, we get the data points, that's the vertical lines, and we compare that to theoretical predictions. And then we figure out what theoretical models best match the data. And then we can get things like this pie chart. We compare the data to the theory. We can figure out that dark energy is a thing that is dominant. Dark matter and atoms, the matter density, is a little subdominant at this present day in time. And just to give you a sense of how we do this, right? Because we want to weigh the galaxy cluster, but you can't put this on a scale in your bathroom, right? This is something very far away. We have to infer or guess what the mass is based on that X-ray energy that they are emitting. Because the more massive they are, the hotter they are. So the more energetic X-ray photons are coming into our telescope. So these are some measurements from the Chandra X-ray telescope over a decade ago now. And the Chandra X-ray telescope is one of the NASA's flagship missions. So this is one of the things that we've gotten data from over the last several decades, like 2 or so. And nowadays we have many more telescopes looking at galaxy clusters in a number of different ways. So I'm just going to leave you with an overall takeaway, right? Galaxy clusters, hundreds to thousands of galaxies gravitationally collapse into this really giant hot ball of X-ray emitting gas, are actually useful tools for us to learn about the history of our universe. So the way I like to end these with the Astro and Tap Talks that I give is just yay beer, because cheers to everything that we can learn, and cheers to everyone who's here. So thank you.
Wow. Thank you, Camille, for
Thank
that
you, Camille.
awesome
Thank you.
talk. Well, I guess after that talk of Camille, we probably need at least a few rounds of beer before we can muster enough guts to shoot our foolish questions, right, Butch? So anyway,
mind-boggling dogs.
Yes, right.
Stop share, Camille.
Okay. Please stop sharing that. Okay, thank you again, Camille.
Thank you,
So,
Camille. Thank
okay,
you.
now the floor is open for questions, both for Camille and Togi. So Brads, who would like to ask a question first?
Okay, Camille, I'd like to ask a question.
Who's this?
Okay.
Hi.
You're discussing about dark energy and gravity. What's the difference between them? Why are they clash? Why is there a clash between them? I know gravity attracts. How about dark matter? Does it attract also? What is the difference between them?
Sure. Okay. Yeah, that's a good question, right? So gravity, yeah, that attracts, right? Dark energy, you can think of it as a repulsive force, so it pushes things apart. Dark matter is subject to gravity because there's a mass, right? Anything with mass, like us and Earth, we are attracted to the Earth. That's why our feet are down on the ground, right? So anything with mass attracts to other things with mass. And dark matter is most of the mass in our universe. Dark energy, we don't know exactly what that is at all, but it is something that we call as the thing that is responsible for a repulsion in our universe. So for galaxies that are far enough apart that they don't feel attracted, they end up being effectively repulsive. They move away from one another, moving quicker and quicker, further and further away.
Okay. Dark matter, is it already there, or is it created by something, or is it already there?
As far as we understand dark matter, it's already there. We don't know much about how it interacts. So we think there's some theories that say some dark matter might annihilate with one another and maybe produce something, but that's highly unlikely given what we can observe. So for the most part, it's been there for most of the history of our universe, but everything was created very early on, shortly after the Big Bang in some way, shape, or form. But for the vast portion of our universe, dark matter is just something that's been sitting there. And it moves around and changes in distribution.
Is that the constant that Einstein is saying? Dark matter is the constant, or dark energy is the constant?
Dark energy is the constant.
But you don't know about, but scientists don't know about dark energy.
That's right. We don't know much about it.
Yes.
So all we know is that as far as we understand, we can parameterize, we can sort of describe this as some constant over the course of our universe. And additional observation can determine how constant it is.
Yeah. How did they find out about dark energy? You know, we didn't hear about that in high school or in college physics. How did they find out about dark energy? When did they find out about it?
So this is something that people have started to notice over the last 30 years, right? The more data you have, the more of an effect you see. So essentially, when we look at distant galaxies, we can measure how quickly they are moving away from us. So you know how an ambulance, when it comes towards you, it sort of sounds like a, that's the blue shifting and the red shifting of sound. So light also does a blue shifting and a red shifting if it's moving towards us or away from us. So we can use the red shift of light coming from different galaxies to measure how quickly they are moving away from us. And what we found was that galaxies that are nearer to us move away from us at a slower velocity, and slower speed than galaxies further away from us. So that means that galaxies further away from us, which are galaxies that existed further back in time. So these are things that are moving faster away from us than the ones closer. So we know that our universe is expanding at an accelerating rate. So the speed is changing over time.
So that's how they found out that there must be something that push it out. And
Yeah.
they said that, but I read also in YouTube that they saw dark energy in the telescope or what? They discovered it.
Dark energy
And
is not something that you can see, right? This is something that we call, right? This is a name we gave to whatever it is that is causing this repulsion to pull things away from one another.
But the one who won the Nobel Prize discovered dark energy. Okay,
Yes.
how did they find out about dark energy? Because of the movement of the
Of light,
these
right?
galaxies.
Yes,
Okay.
and they use what are called supernovae in order to track how quickly it's moving away. The supernovae are exploding stars, and what people realize is that when stars explode, when they explode in a certain way, they emit the same amount of light. They're just as bright. So if you know exactly how bright something is, you can tell how far away it is. So these are called standard candles, right? If you imagine lighting the same size candle, putting it, 1 foot away from you versus 10 feet away, right? It dims. But if you light a brighter candle, a bigger candle versus a smaller candle, you can't tell by the brightness how far away it is from you. You need the same kind of candle to figure out how far away that light is because it dims as it goes further and further away.
Hey,
But
right.
Others ask first before I ask
Yeah.
again.
Okay. Hi. Thank you. Butch, I believe you have a question, Butch. Please shoot your question.
Dodge, it boggles my mind, Dodge. Hi, Camille. Hi, good afternoon. Good morning. Thank you very much for the wonderful topic. I've been interested in astronomy since I was about 5 or 6 years old when my dad told me to count the stars. So that's how I got hooked. But I'm more on the observational side, just more stargazing actually, not really astronomy in the strict sense of the word. I've been trying to read up on dark matter and dark energy for as long as I can remember when I first got internet, and until now it still boggles my mind. I really can't grasp it. Now, my just one question: if you say that gravity existed at the start of closer to the Big Bang, and the farther away we go from the Big Bang, that's when dark energy starts kicking in. So my question is, where did the dark energy come from? I mean, if it wasn't there before and it's now here, where did it come from?
We don't know. That's one of the big
Asking where the
questions.
universe came from.
We don't know at all,
We don't
right?
know.
This is
Yeah.
the reason we still are employed in my field, because there's so many questions we still don't understand. So the different aspects of dark energy, how it behaves, we treat it like a cosmological constant because that's as far as the observations tell us is consistent with that. But to really break, you want to cancel out, you want to, sorry, I think someone's not muted. You want, when you make measurements, you want the measurements to be able to cancel out theories so you can narrow down on exactly what's going on. And we haven't been able to do that thus far.
Okay,
But
thank you,
I
Camille.
do want to say that you've like since 5, your interest in astronomy has been longer than mine, because my interest in astronomy didn't happen until I was in my early 20s, until after I finished a lot of school already.
Yeah,
Yeah.
but you're a very higher level than me, Camille. Mine is just observational. Thank you so much for
Okay.
the talk.
Okay.
Thank you so much for the question.
Yeah. There's
Can
okay.
I ask a question?
Okay, Kading. Roses.
Can I ask
okay.
a question?
Okay.
Camille, good morning. I'm not really, let's say, with that, but I don't know if this is related to your field, astronomy. As they said, life is interconnected on Earth. Is it true that our lives, our daily lives, things, events happening on Earth, they're really influenced by this astrology, is it true? Or by the movement of space, time, so on and so on. You get what I mean?
Sorry, Dito, let me just make sure I understand your question. You're asking if our lives are influenced by space time, or
Yeah, like horoscope, like astrology, something like that.
Okay.
Yeah.
So actually, for that, the horoscopes, the alignment of all of what the horoscopes that you read are based on, they're based on alignments that are actually no longer aligned, right? Because over time, the cycle will offset. So I do think that the horoscopes are I enjoy reading them. They're a lot of fun, but you'll be surprised to hear that the alignment, what they're basing them on, is not quite where everything actually lies, because right, if you sort of think of a different cadence of things rotating, things don't align in the same way that the horoscopes have been based on for years.
Okay. Right.
Yeah.
Thank you.
Can I ask
Okay.
another question,
Yeah.
Dodge?
Okay. Shoot, Butch.
Oh, yes, Camille. I was reading up on this. I've got the name.